Langchain Anthropic Chat Models. Description: Langchain Anthropic Chat Models are a powerful combination of Langchain's modularity and Anthropic's advanced language models. Langchain provides a framework for connecting and orchestrating different components, including chat models, while Anthropic offers access to state-of-the-art models like Claude. This integration enables users to build sophisticated conversational AI applications that leverage the strengths of both technologies. Inputs: prompt: the user's input or question, which is sent to the Anthropic model for processing. Model parameters: various parameters can be set to influence the model's behavior, such as temperature for randomness, top for probability filtering, and max tokens for output length. Outputs: model response: the Anthropic model's generated text response based on the input prompt and parameters. Metadata: information about the generated response, including model name, token usage, and timestamps. Steps: prompt formulation: the user's input is formatted and preprocessed for compatibility with the Anthropic API. Model invocation: the formatted prompt is sent to the Anthropic model for processing. Response handling: the model's response is received, decoded, and presented to the user. Metrics: token usage: the number of tokens used in both the input prompt and the model's response, which can be used to track costs and optimize performance. Response quality: evaluates the relevance, coherence, and accuracy of the model's response through subjective or objective measures. Visualization plots: token usage over time: a plot that tracks the number of tokens used over multiple interactions, highlighting potential trends or fluctuations. Response length distribution: a histogram representing the distribution of response lengths, providing insights into the model's tendencies. Fine-tune parameters: model selection: choosing the appropriate Anthropic model, e.g., CLAUDE2, Claude Instant, based on the specific task and desired trade-off between performance and cost. Temperature controls the randomness of the model's output, with higher temperatures producing more creative and unpredictable responses. Top: a probability filtering mechanism that restricts the model's output to tokens with a combined probability exceeding a threshold, ensuring higher quality and coherence. Max tokens limits the maximum number of tokens in the model's output, preventing excessively lengthy responses. Uncertainty methods: confidence scores: Anthropic models often provide confidence scores associated with their generated tokens, offering insights into the model's uncertainty. Multiple model outputs running the same prompt through different Anthropic models can reveal variations in responses, indicating potential areas of uncertainty. Challenges and fixes. Challenge 1: bias in model responses. Anthropic models, like other large language models, can exhibit biases based on the data they were trained on. Sample use case that resulted in challenge 1: a prompt asking for information about a specific profession might disproportionately generate responses related to traditionally male-dominated fields. Fixes to challenge 1: implement bias mitigation techniques during model training or fine-tuning. Use prompt engineering to guide the model towards more balanced and inclusive responses. Provide feedback to the model developers to help improve data quality and reduce biases. Challenge 2: lack of factual accuracy. While Anthropic models are advanced, they may sometimes generate responses that are factually incorrect or lack supporting evidence. Sample use case that resulted in challenge 2: a prompt asking for a specific historical event might generate a response that contains inaccuracies or misinterpretations. Fixes to challenge 2: incorporate fact-checking mechanisms into the workflow. such as verifying information against reputable sources. Use external knowledge sources to enrich the model's responses and improve accuracy. Encourage user feedback to highlight factual errors and help refine the model's knowledge base. Challenge 3. Difficulty with complex tasks. Anthropic models may struggle with tasks that require intricate reasoning, logic, or multi-step problem solving. Sample use case that resulted in Challenge 3. A prompt asking the model to generate a complex code snippet or solve a challenging logical puzzle might result in an incomplete or incorrect response. Fixes to Challenge 3. Break down complex tasks into smaller, more manageable steps. Use specialized prompts that guide the model through the reasoning process. Integrate external tools or APIs to handle specific aspects of complex tasks. Langchain Anthropic Chat Models. Anthropic Tool. Description. Explain in detail. The Anthropic tool is a Langchain tool that enables interaction with Anthropic's Claude models. It provides a simple way to leverage Claude's capabilities within a Langchain application. Inputs. Input 1. Explain in detail the prompt or question that you want Claude to respond to. This input is typically a string. Outputs. Output 1. Explain in detail the response generated by Claude, which is also a string. Steps. Step 1. Explain in detail the tool takes your prompt as input. Step 2. Explain in detail it sends the prompt to the Claude model specified in the configuration. Step 3. Explain in detail it receives the response from the Claude model and returns it as the output. Metrics. Metric 1. Explain in detail evaluation metrics for Claude's performance can include accuracy, assessing the correctness of the generated responses. Coherence, measuring the fluency and logical flow of the output. Relevance, evaluating how well the response aligns with the input prompt. Visualization plots. Visualization plot 1. Explain in detail. Visualizations can be created to analyze the performance of Claude across different tasks or prompts. For example, you can plot the distribution of response lengths or create heat maps to highlight areas where the model performs well or poorly. Fine-tune parameters. Parameter 1. Explain in detail. Anthropic tool typically doesn't involve fine-tuning the Claude model itself. However, if you are using a custom Claude model, you might have specific parameters for its configuration, such as temperature, top, and top, which can influence the model's creativity and randomness in generating responses. Uncertainty methods. Uncertainty method 1. Explain in detail. Claude can provide uncertainty estimations on its responses. This can be achieved through techniques like confidence scores. Claude may output a confidence score alongside its response, indicating the model's certainty about its answer. Probabilistic outputs. Instead of just a single response, Claude can provide a probability distribution over multiple possible responses, showcasing the model's uncertainty about the best output. Challenges and fixes. Challenge 1. Explain in detail. Handling long prompts or context. Claude may have limitations in processing extremely long prompts or contexts. Sample use case that resulted in Challenge 1. When providing a very long article as context, Claude might fail to incorporate all the information effectively. Fixes to Challenge 1. Break down the long prompt into smaller chunks and process them iteratively. Use techniques like summarization or keyword extraction to distill the key information before feeding it to Claude. Challenge 2. Explain in detail. Maintaining conversation coherence in multi-turn conversations. Claude might lose track of the context and provide responses that are not consistent with the previous turns. Sample use case that resulted in Challenge 2. When asking follow-up questions in a conversation, Claude may forget earlier parts of the dialogue and provide responses that don't make sense in pay. Context. Fixes to challenge 2. Implement a memory mechanism to store and recall previous conversation turns. Use techniques like prompt engineering to guide Claude to maintain coherence and track context. Explicitly provide the previous conversation turns as part of the input prompt. Challenge 3. Explain in detail limited access to external information. Claude is not inherently connected to external databases or APIs, so it might not have access to up-to-date information or specific knowledge domains. Sample use case that resulted in challenge 3. When asking for information about a recent event or a specific technical topic, Claude might not have the necessary knowledge. Fixes to challenge 3. Integrate Claude with other Langchain tools that can access external databases or APIs to retrieve the required information. Use prompt engineering to guide Claude to identify and use appropriate external resources. Langchain Anthropic Chat Models. Chat Anthropic description. Explain in detail. Chat Anthropic is a Langchain wrapper for Anthropic's Claude 2 API, allowing you to interact with the powerful language model within Langchain's framework. It enables seamless integration of Claude 2's capabilities into various Langchain applications, including conversational agents, text generation, and more. Inputs. Input 1. Explain in detail prompt string. This is the text input to CLAUDE2. It can be a question, a statement, or a more complex instruction. CLAUDE2 will process this prompt and generate a response based on its understanding and knowledge. Input 2. Explain in detail temperature float. Optional. This parameter controls the randomness and creativity of the response. Higher values lead to more diverse and potentially more surprising responses, while lower values produce more predictable and deterministic results. Outputs. Output 1. Explain in detail text string. The generated response from CLAUDE2 based on the input prompt. Output 2. Explain in detail model name string. The specific name of the Anthropic model used, e.g. CLAUDE2. Steps. Step 1. Explain in detail. The Chat Anthropic class interacts with the Anthropic API using the Anthropic library. Step 2. Explain in detail. It sends the provided prompt to CLAUDE2 along with any specified parameters like temperature. Step 3. Explain in detail. It receives the generated response from CLAUDE2 and returns it as text. Metrics. Metric 1. Explain in detail model name string. The name of the Anthropic model used for the request. Metric 2. Explain in detail time taken float. The duration taken for the request to be processed and the response to be generated. Visualization plots. Visualization plot 1. Explain in detail. No specific visualization plots are inherently associated with Chat Anthropic. You can create plots based on the responses generated by Claude 2, e.g. text length distributions. Sentiment analysis. Visualization plot 2. Explain in detail. The Anthropic library itself doesn't offer built-in visualizations. Fine-tune parameters. Parameter 1. Explain in detail. No fine-tuning is directly available for CLAUDE2. It is a pre-trained model, and Anthropic manages its updates. Parameter 2. Explain in detail. You can control the model's behavior through parameters like temperature, which can be adjusted based on the desired level of randomness and creativity. Uncertainty methods. Uncertainty method 1. Explain in detail. Chat Anthropic doesn't provide explicit uncertainty measures. However, you can leverage the temperature parameter to explore different possibilities and potentially gain insights into the model's uncertainty. Uncertainty method to explain in detail. Anthropic's API doesn't expose specific confidence scores or uncertainty metrics for generated responses. Challenges and fixes. Challenge 1. Explain in detail API key management. It's essential to securely manage your Anthropic API key. Sample use case that resulted in Challenge 1. Accidentally exposing the key in your code. Storing it in a publicly accessible location. Fixes to Challenge 1. Store your API key in a secure environment, e.g. environment variables, and avoid hardcoding it into your code. Utilize tools like AWS Secrets Manager or similar services for key management. Challenge 2. Explain in detail rate limiting. Anthropic imposes rate limits to prevent excessive usage of the API. Sample use case that resulted in Challenge 2. Submitting a large number of requests in a short time frame. Fixes to Challenge 2. Implement throttling mechanisms to limit your API requests and avoid hitting the rate limit. Monitor your usage and adjust your request frequency accordingly. Langchain Anthropic Chat Models. Chat Anthropic Messages. Description: the Chat Anthropic Messages class is used to format messages for the Anthropic API in Langchain. It ensures the correct structure for both user and assistant messages, facilitating seamless communication with Anthropic models. Inputs: messages, a list of dictionaries, each representing a message in the conversation. Each dictionary should have a role key specifying either human or assistant, and a content key containing the message text. Outputs: formatted messages, a list of dictionaries, each representing a message formatted according to the Anthropic API's requirements. Steps: the class iterates through the provided messages. For each message, it determines the role human or assistant. It constructs a dictionary with keys name, content, and role, ensuring compatibility with Anthropic's API format. Metrics: NA. Visualization plots: NA. Fine-tune parameters: NA. Uncertainty methods: NA. Challenges and fixes. Challenge 1. Handling non-standard message formats. Sample use case that resulted in Challenge 1. Providing messages that lack the role or content keys. Fixes to Challenge 1. The class gracefully handles invalid message formats by attempting to extract relevant information and logging any errors for debugging purposes. Challenge 2. Integrating with different Langchain components. Sample use case that resulted in Challenge 2. Using Chat Anthropic messages with chain-based or agent-based systems where custom message structures are used. Fixes to Challenge 2. The class can be extended or modified to accommodate diverse message structures by allowing customization of the role and content keys. YAML. Langchain Anthropic Chat Models Convert to Anthropic Tool. Description: the Convert to Anthropic Tool function takes a Langchain Anthropic Chat model and transforms it into a format compatible with Anthropic's tool integration system. This allows you to seamlessly integrate the model's capabilities into your own applications and workflows. Inputs: model: the Langchain Anthropic Chat model you want to convert. This model should be an instance of Anthropic.API, Anthropic, or a compatible subclass. Tool name: the name of the tool that will be created for this model. This name should be descriptive and reflect the tool's purpose. Tool description: a detailed description of the tool, explaining its functionality and intended use. This should be helpful for users who want to understand how the tool works. Outputs: tool configuration: a dictionary containing the tool's name, description, and other configuration details. This configuration is compatible with Anthropic's tool integration framework. Tool function: a function that encapsulates the model's behavior and serves as the entry point for Using the tool. This function takes user input, interacts with the model, and returns the model's output. Steps. Initialize the tool. The function creates an empty dictionary to hold the tool configuration. Populate tool configuration. The name and description of the tool are added to the configuration. Dictionary. Define tool function. A function is defined that accepts user input as an argument. Model interaction. The function passes the user input to the Anthropic model and retrieves the model's response. Format output. The function formats the model's response into a consistent format suitable for the tool's output. Return tool configuration and function. The function returns the completed tool configuration. Dictionary and the tool function. Metrics. Accuracy. This metric assesses the tool's ability to produce correct and relevant outputs based on user input. Latency. This metric measures the time it takes for the tool to process user input and return a response. User satisfaction. This metric evaluates how well the tool meets users' expectations and how easy it is to use. Visualization plots. Response time histogram. A histogram depicting the distribution of response times for different user inputs. Accuracy vs. input length. A scatter plot showing the relationship between the length of user inputs and the accuracy of the tool's responses. Fine-tune parameters. Model parameters. Anthropic models often have various parameters that can be adjusted during fine-tuning to optimize their performance for specific tasks or domains. Tool-specific parameters. You might introduce additional parameters that are specific to the tool and its intended use. Uncertainty methods. Confidence score. The model might provide a confidence score for its responses, indicating its level of certainty. Ensemble methods. You can use ensemble methods to combine predictions from multiple models, reducing uncertainty and improving robustness. Challenges and fixes. Challenge 1. Model output format. The Anthropic model might return output in a format that is not directly compatible with the tool's output format. Sample use case that resulted in challenge 1. The model might return a list of items, but the tool requires a dictionary. Fixes to challenge 1. The tool function can include logic to convert the model's output into the required format. For example, you might use a loop to iterate through the list and create a dictionary. Challenge 2. Ambiguous user input. The tool might encounter ambiguity in user input, leading to incorrect or irrelevant responses from the model. Sample use case that resulted in challenge 2. The user might provide incomplete or poorly defined instructions, making it difficult for the model to understand their intent. Fixes to challenge 2. You can implement input validation or incorporate techniques like prompt engineering to clarify user input and reduce ambiguity. For example, you could use a series of prompts to guide the user through providing more precise instructions. Langchain Anthropic Experimental Description. Explain in detail. This experimental feature in Langchain allows you to use Anthropic's powerful Claude models directly within your Langchain applications. It offers access to Anthropic's advanced language capabilities, including text generation, summarization, translation, and more. Inputs. Input 1. Explain in detail. Text input. This is the primary input to the Anthropic models. It can be a string of text, a document, or a URL. Input 2. Explain in detail model parameters. This includes parameters such as model name e.g. CLAUDE2, temperature, top, and max tokens, which control the behavior of the Anthropic model. Outputs. Output 1. Explain in detail generated text. The Anthropic model processes the input and produces output in the form of text. This can be a generated response, a summary, a translation, or other text-based results. Output 2. Explain in detail model output metadata in addition to the generated text. Anthropic models may also provide metadata about the response, such as the number of tokens used, the time taken for processing, and other relevant information. Steps. Step 1. Explain in detail initialization. The Langchain Anthropic integration first initializes a connection to the Anthropic API. Step 2. Explain in detail model selection. You specify the Anthropic model you want to use, e.g. Claude 2, by providing the appropriate model name as a parameter. Step 3. Explain in detail input processing. The input text is pre-processed, tokenized, and prepared for the Anthropic model. Step 4. Explain in detail API call. The processed input is sent to the Anthropic API for processing. Step 5. Explain in detail response handling. The API response, containing the generated text and metadata, is received and interpreted by Langchain. Metrics. Metric 1. Explain in detail accuracy. This metric evaluates the quality of the generated text by comparing it to a reference text or a ground truth. It assesses how well the model fulfills the intended task. Metric 2. Explain in detail fluency. This metric measures the readability and coherence of generated text. It assesses whether the output is grammatically correct and flows smoothly. Metric 3. Explain in detail relevance. This metric evaluates how well the generated text addresses the input prompt or question. It assesses whether the output is relevant and provides useful information. Metric 4. Explain in detail token usage. This metric tracks the number of tokens used by the Anthropic model for processing the input. It helps understand the computational resources required. Metric 5. Explain in detail latency. This metric measures the time taken by the Anthropic model to generate a response. It assesses the model's processing speed. Visualization plots. Visualization plot 1. Explain in detail token usage over time. This plot visualizes the number of tokens consumed by the Anthropic model during processing. It can help identify patterns in resource usage and optimize parameters. Visualization plot 2. Explain in detail latency distribution. This plot shows the distribution of response times for different inputs and model configurations. It helps assess the model's consistency and performance. Visualization plot 3. Explain in detail accuracy vs temperature. This plot investigates the relationship between the temperature parameter and the accuracy of the generated text. It helps identify the optimal temperature settings for different tasks. Fine-tune parameters. Parameter 1. Explain in detail temperature. This parameter controls the randomness of the model's output. Higher temperatures produce more creative and diverse responses, while lower temperatures generate more predictable and deterministic outputs. Parameter 2. Explain in detail top. This parameter is used for nucleus sampling, which selects tokens based on their probability distribution. A lower top value limits the range of potential tokens, leading to more focused and predictable outputs. Parameter 3. Explain in detail max tokens. This parameter limits the maximum number of tokens that the model will generate. It helps control the length of the output and prevent excessive generation. Uncertainty methods. Uncertainty method 1. Explain in detail temperature sampling. Using temperature allows you to explore different levels of randomness and uncertainty in the model's output. Higher temperatures introduce more uncertainty, while lower temperatures reduce uncertainty. Uncertainty method 2. Explain in detail top K sampling. This method selects the top K most likely tokens at each step, introducing uncertainty by choosing randomly among these K tokens. Challenges and fixes. Challenge 1. Explain in detail API rate limiting. The Anthropic API may impose rate limits on pay. Number of requests you can make per second or per minute. Sample use case that resulted in challenge 1. You are using the Anthropic model within a loop to process a large volume of text, exceeding the API's rate limits. Fixes to challenge 1. Implement a mechanism to throttle your requests, ensuring you stay within the API's limits. You can use techniques like exponential backoff or a token bucket algorithm to manage requests and avoid exceeding the limits. Challenge 2. Explain in detail token consumption. The Anthropic models can be computationally expensive, especially for long inputs or complex tasks. Sample use case that resulted in challenge 2. You are processing a very long document and the model consumes a large number of tokens, leading to high costs. Fixes to challenge 2. Consider techniques like text summarization or chunking to reduce the input size. You can also experiment with different model sizes to find a balance between performance and cost. Challenge 3. Explain in detail latency issues. The Anthropic API may experience latency, resulting in delays in responses. Sample use case that resulted in challenge 3. You are using the model in a real-time application, and the latency is causing delays in the user experience. Fixes to challenge 3. Implement strategies like caching responses or using asynchronous API calls to minimize the impact of latency. Consider using a local cache to store frequently accessed responses, which can reduce the need for frequent API calls. Challenge 4. Explain in detail model bias. Like all language models, Anthropic models can exhibit biases based on the data they were trained on. Sample use case that resulted in challenge 4. The model generates text that reflects harmful stereotypes or prejudices. Fixes to challenge 4. Be aware of potential biases in the model's output. Implement strategies like prompt engineering or using diverse training data to mitigate biases. Consider using techniques to identify and mitigate biases, such as fairness-aware training methods or bias detection tools. Challenge 5. Explain in detail input validation. Incorrect or poorly formatted input can cause errors or unexpected results from the Anthropic model. Sample use case that resulted in challenge 5. You provide an input that is not in the expected format, leading to an API error. Fixes to challenge 5. Implement rigorous input validation before sending data to the Anthropic model. Ensure that inputs are in the correct format, length, and structure. You can use libraries or custom functions to validate inputs and handle errors gracefully. Challenge 6. Explain in detail error handling. The Anthropic API may return errors or exceptions. Sample use case that resulted in challenge 6. The model encounters an error during processing, such as a network issue or an internal server error. Fixes to challenge 6. Implement robust error handling mechanisms to gracefully manage API errors. You can catch exceptions, log errors, and provide informative messages to the user. Consider retrying requests or implementing exponential backoff strategies to handle transient errors. Langchain Anthropic Experimental Chat Anthropic Tools. Description: the Chat Anthropic Tools class is a tool that provides a simple way to access the Anthropic API from Langchain. It allows you to interact with Anthropic's Claude model and leverage its capabilities for various tasks. Inputs. Prompt: the prompt or question you want to ask Claude. This is the primary input that determines the response. It can be a text string, a list of prompts, or a structured input depending on the specific use case. Model name: the name of the Anthropic model you want to use. This defines the specific Claude model version and its associated capabilities. The available models can vary based on the Anthropic API configuration. Outputs. Response: the output generated by Claude based on the prompt and model configuration. This can be a text string, a list of responses, or a structured output depending on the task and model capabilities. Metadata: additional metadata associated with the response, such as the model name, the generation time, and any other relevant information provided by the Anthropic API. Steps. Input: handling: the Chat Anthropic Tools class receives the prompt and model name as input. API call: the class sends a request to the Anthropic API with the provided prompt and model name. Response: processing: the class receives the response from the API, extracts the text response, and any other associated metadata. Output: formatting: the class formats the output as a dictionary containing the response and metadata for further use in Langchain pipelines. Metrics. Time taken: this measures the time taken to complete the request and receive the response from the Anthropic API. Response length: this measures the length of the text response generated by Claude. Visualization plots. Response length distribution: a histogram showing the distribution of response lengths for different prompts. Time taken distribution: a histogram showing the distribution of time taken for different requests. Fine-tune parameters. Temperature: this parameter controls the randomness and creativity of the response. Higher values lead to more unpredictable responses. Top: this parameter controls the number of candidate responses considered during generation. Top: this parameter controls the probability distribution of candidate responses. Uncertainty methods. Confidence scores: the Anthropic API may provide confidence scores for different parts of the response, indicating the model's certainty about the generated text. Probability distributions for tasks like text classification. The model may provide probability distributions over different classes, indicating the likelihood of each class. Challenges and fixes. Challenge 1: rate limiting: the Anthropic API may impose rate limits to prevent abuse and ensure fair access for all users. Sample use case that resulted in Challenge 1: sending a large number of requests in a short period of time. Fixes to Challenge 1: implement a rate limiter on the client side to ensure that the API calls are within the allowed rate limits. Use a retry mechanism to handle temporary rate limits. Challenge 2: input length limitations: the Anthropic API may have input length limitations, which can limit the complexity and length of prompts that can be processed. Sample use case that resulted in Challenge 2 providing a very long and complex prompt that exceeds the input length limit. Fixes to Challenge 2: break down the prompt into smaller chunks that fit within the input length. Limitations. Consider using a summarization or text compression tool to shorten the prompt before sending it to the API. Challenge 3: response format inconsistency: the format of the response from the Anthropic API may vary depending on the model and the task. Sample use case that resulted in Challenge 3 requesting different tasks from the API, such as text generation, summarization, and translation. Fixes to Challenge 3: implement robust parsing mechanisms to handle different response formats. Design a consistent output format for the Chat Anthropic Tools class to ensure predictable output for different tasks. Challenge 4: API availability: the Anthropic API may be temporarily unavailable due to maintenance or other unforeseen issues. Sample use case that resulted in Challenge 4 trying to send a request to the API during a scheduled maintenance window or during a network outage. Fixes to Challenge 4: implement a retry mechanism with exponential backoff to handle temporary API unavailability. Monitor the API health and provide appropriate error handling for network errors. YAML. Langchain Anthropic Experimental Get System Message. Description: this function is designed to generate a system message that can be used with the Anthropic Claude model within the Langchain framework. Inputs. Model name: this input specifies the Anthropic Claude model variant to be used for generating the system message. Task: the task input defines the specific objective or purpose of the system message. This input clarifies what the AI assistant should do. Persona: the persona input defines the personality or character of the AI assistant. This can be used to tailor the IS responses to match a specific style or tone. Tools: this input allows specifying the set of tools that the AI assistant can utilize. These tools could include external APIs, databases, or other resources. Memory: this input defines the memory capacity of the AI assistant. This allows the AI to remember past interactions and context for a more natural and coherent conversation. Verbose: this input determines the level of detail in the system message. Setting this to true will result in a more verbose message with more explanations and instructions. Outputs. System message: this output is a string containing the generated system message. The system message will be customized based on the provided inputs. Steps. The function takes the user-provided inputs as parameters. Based on the input values, the function constructs a tailored system message. The system message includes instructions for the Anthropic Claude model, defining the task, persona, tools, memory, and other relevant parameters. Metrics. Quality of generated system message: this metric evaluates how effectively the system message guides the Anthropic Claude model to produce the desired output. Relevance of the generated system message to the specific task: this metric evaluates the alignment of the system message with the intended purpose or objective. Visualization plots. Not applicable. Fine-tune parameters. Not applicable. Uncertainty methods. Not applicable. Challenges and fixes. Challenge 1: the system message might not be sufficiently clear or concise, leading to unexpected or inaccurate responses from the AI assistant. Sample use case that resulted in challenge 1: providing a vague task description or failing to specify tools correctly can result in the AI assistant struggling to understand the intended objective. Fixes to challenge 1: ensure the task description is clear and specific. Carefully define the tools that the AI assistant should use. Challenge 2: the system message may not be flexible enough to handle various inputs or variations in user requests. Sample use case that resulted in challenge 2: using a rigid system message that does not allow for user input or context can limit the AI assistant's ability to engage in a dynamic conversation. Fixes to challenge 2: employ parameterized system messages that can adapt to different inputs. Utilize context-aware approaches to allow the AI assistant to understand and respond to evolving conversations. Langchain Anthropicals. Description: the Langchain Anthropic LLM integration allows you to interact with Anthropic's Claude LLM models within your Langchain applications. This integration provides a seamless way to leverage Claude's capabilities for tasks like text generation, summarization, translation, question answering, and more. Inputs. Model name: the name of the Anthropic Claude model you want to use. Anthropic offers various models with different capabilities and pricing. API key or API key from Anthropic. This key is essential for authenticating requests to the Anthropic API. Temperature: this parameter controls the creativity and randomness of the model's responses. Higher temperature values, e.g., 1.0 lead to more creative and unpredictable outputs, while lower values e.g. 0.0 produce more deterministic and predictable responses. Max tokens. This parameter limits the maximum number of tokens the model can generate in a response. You can use this to control the length of the output. Stop sequences specify specific sequences of text to indicate the model should stop generating text. This can be useful for preventing the model from going off topic or generating unwanted content. Outputs. Response text. The generated text response from the Claude model. This can be a variety of outputs depending on the prompt and task, such as summaries, translations, code, creative writing, and more. Steps. Initialize Langchain. Import the necessary Langchain modules and create a Langchain chain or agent. Define the Anthropic LLM. Specify the model name, your Anthropic API key, and any other desired parameters. Temperature. Max tokens. Stop sequences. Send a prompt. Provide a clear and well-defined prompt to the Anthropic model. Receive the response. The model generates a response based on the prompt and the configured parameters. Process the response. Langchain handles the formatting and processing of the response, making it easy to use within your applications. Metrics. API call latency. Measure the time taken for the model to process the prompt and return a response. Response quality. Assess the quality of the generated text, considering its relevance, coherence, accuracy, and overall usefulness. Visualization plots. Response length distribution. Plot the distribution of response lengths across multiple prompts or tasks. This can help understand the model's tendency to generate longer or shorter outputs. API call latency distribution. Visualize the distribution of API call latencies to understand the consistency and performance of the Anthropic API. Fine-tune parameters. Temperature. Experiment with different temperature values to fine-tune the model's creativity and randomness for your specific needs. Max tokens. Adjust the maximum number of tokens to control the length of the model's responses based on your use case. Stop sequences. Tailor the stop sequences to guide the model's output and prevent unwanted content generation. Uncertainty methods. Confidence scores. Anthropic models can provide confidence scores for their generated text. You can use these scores to gauge the model's certainty about its response and decide whether to rely on it or not. Temperature scaling. The temperature parameter can influence the uncertainty of the model's response. Higher temperature values introduce more randomness, potentially leading to more uncertainty in the output. Challenges and fixes. Challenge 1. The model may generate outputs that are repetitive, incoherent, or factually incorrect. Sample use case. When prompted to write a creative story, the model might produce a repetitive and nonsensical narrative. Fixes. Refine your prompts. Provide clear and specific instructions to guide the model's output. Use stop sequences. Specify sequences of text that signal the model to stop generating content to prevent repetition. Experiment with temperature. Adjust the temperature parameter to influence the randomness and creativity of the model's response. Challenge 2. The model might be prone to biases and ethical concerns, reflecting biases present in the training data. Sample use case. The model might generate responses with harmful stereotypes or discriminatory language when prompted with certain sensitive topics. Fixes. Anthropic's safety guidelines. Refer to Anthropic's guidelines for ethical use and safety best practices. Bias mitigation techniques. Explore and implement techniques for mitigating biases in language models, such as data augmentation, adversarial training, or debiasing algorithms. Human oversight in sensitive applications. Consider incorporating human review and oversight to ensure ethical and responsible use of AI. Model. Challenge 3. The Anthropic API might experience latency or downtime, impacting the availability of the model. Sample use case during periods of high usage or server maintenance. The API might respond slowly or become unavailable. Fixes. Error handling. Implement mechanisms to handle potential errors or delays in API responses. Retry mechanisms include retry logic in your code to attempt the API request again in case of failures. Monitoring and alerting. Monitor the API's performance and set up alerts to notify you of any issues. Challenge 4. The cost of using Anthropic models might be a factor, especially for high volume or production applications. Sample use case. If you are using the model for a large number of requests, the cost of API calls can accumulate rapidly. Fixes. Model selection. Choose the appropriate Anthropic model based on your budget and the required capabilities. Optimizing prompts. Craft efficient and concise prompts to reduce the number of tokens generated, thereby lowering costs. Batching requests. Process multiple prompts together to reduce the overhead of individual API calls. Langchain Anthropic LLMs. Anthropic. Description. The Langchain Anthropic LLMs Anthropic class provides a simple interface for interacting with Anthropic's Claude API using Langchain. It enables you to send requests to the Claude API, receive responses, and process them within your Langchain applications. Inputs. Model. The name of the Anthropic model to use. For example, CLAUDE2. Temperature controls the randomness of the generated text. Higher values lead to more diverse and unpredictable outputs. Max tokens. The maximum number of tokens to generate in the response. Top. A probability threshold for nucleus sampling. Top. The number of highest probability tokens to consider during sampling. Stream. Whether to stream the response or not. Stop. A sequence of tokens at which to stop generating text. Prompt. The input prompt to the model. Outputs. Response. The generated text from the Anthropic model. Steps. Initialize the Anthropic LLM using the Langchain Anthropic library. Prepare the input prompt. Send the prompt to the Anthropic API using the initialized LLM object. Receive the generated response from the API. Process the response as needed within your Langchain application. Metrics. Perplexity measures how well the generated text matches the expected language patterns. Blue score evaluates the quality of machine translation outputs. Visualization plots. Token distribution plot visualizes the frequency of different tokens generated by the model. Attention heat map illustrates the attention weights assigned by the model to different parts of the input prompt. Fine-tune parameters. Learning rate controls the step size during model training. Batch size. The number of samples used in each training iteration. Epochs. The number of times the entire training dataset is processed. Uncertainty methods. Temperature sampling introduces randomness in the model's predictions. Top K sampling selects the top K most probable tokens during generation. Challenges and fixes. Challenge 1. API rate limiting. Sample use case that resulted in Challenge 1 sending a high volume of requests to the Anthropic API might trigger rate limiting, resulting in errors or delays. Fixes to Challenge 1. Implement a rate limiting mechanism in your code to ensure that you are not exceeding the API's usage limits. This can involve introducing delays between requests or using a queue to buffer requests. Challenge 2. Model inconsistency. Sample use case that resulted in Challenge 2. The Anthropic model might produce inconsistent responses across different invocations, leading to unexpected or unpredictable behavior. Fixes to challenge 2. Carefully design your prompt engineering to ensure consistent and clear instructions. You can also try different model configurations or parameters to identify settings that yield more stable results. Challenge 3. Token length limits. Sample use case that resulted in challenge 3 exceeding the maximum allowed token length for the Anthropic model can result in truncation of the input prompt or the generated output. Fixes to challenge 3. Carefully manage the length of your prompts and outputs to stay within the token limits. You might need to break down lengthy inputs into smaller segments or use a technique like text summarization to reduce the overall token count. Langchain Anthropic LLMs. Anthropic LLM. Description: the Anthropic LLM class in Langchain provides an interface to Anthropic's Claude models. It allows users to interact with Claude and leverage its capabilities for various tasks like text generation, summarization, and question answering. Inputs. Text: the input text that you want to send to the Anthropic model. This could be a prompt, a question, or any other text you want the model to process. Temperature: this parameter controls the randomness of the model's output. A higher temperature results in more creative and unpredictable outputs, while a lower temperature produces more deterministic and focused responses. Max tokens: this parameter limits the maximum number of tokens the model can generate in its response. It helps control the length of the generated text. Top: this parameter, also known as nucleus sampling, controls the diversity of the model's output. It selects a subset of the most likely tokens based on their probability, ensuring a more focused and coherent response. Top: this parameter, known as top K sampling, selects the top K most probable tokens for generation. Similar to top, it helps control the diversity and focus of the model's output. Model specifies the Claude model you want to use. This could be CLAUDE2 or Claude INSTANT1 depending on your needs. Outputs. Text: the generated text output by the Anthropic model. This could be a story, a summary, an answer to a question, or any other text generated based on the input prompt. Steps. The Anthropic LLM class interacts with Anthropic's API to send the input text and parameters to the chosen Claude model. The model processes the input and generates a response. The generated text is returned to the Langchain application for further use or display. Metrics. Accuracy: evaluating the correctness and quality of the generated text against a set of predefined criteria or ground truth. Fluency: measuring the smoothness and naturalness of the generated text. Relevance: assessing how well the generated text aligns with the input prompt or context. Coherence: evaluating the logical flow and consistency of the generated text. Visualization plots. Word cloud: visualizing the frequency of words used in the generated text to understand the dominant themes or topics. Topic modeling: identifying clusters of related words or concepts within the generated text. Sentiment analysis: visualizing the overall sentiment expressed in the generated text. Fine-tune parameters. Learning rate: the rate at which the model's parameters are adjusted during the fine-tuning process. Epochs: the number of times the training dataset is iterated over during fine-tuning. Batch size: the number of samples processed at once during each training iteration. Uncertainty methods. Temperature scaling: adjusting the temperature parameter can introduce more uncertainty and explore a wider range of possibilities. Top K sampling: selecting a lower value for top K can introduce more randomness and uncertainty in the model's output. Ensemble methods combining predictions from multiple models with different parameters can improve uncertainty estimation. Challenges and fixes. Challenge 1: limited context understanding. The Anthropic model may struggle to understand the context of long or complex inputs. Sample use case that resulted in Challenge 1: a user provided a long and detailed article and asked the model to summarize it. The model may only capture the main points or omit some important information due to its limited context window. Fixes to Challenge 1. Break down the input into smaller chunks to improve context understanding. Use a model with a larger context window if available. Provide additional context or background information to assist the model. Challenge 2: bias and fairness. The model's output may reflect biases present in the training data. Sample use case that resulted in Challenge 2: a user asked the model to generate a story about a scientist. The model might produce a story with stereotypical gender roles due to biases present in the training data. Fixes to Challenge 2. Use a model that has been trained on a diverse and inclusive dataset. Use techniques like the biasing or fairness-aware training to mitigate biases. Carefully evaluate and monitor the model's output for any signs of bias. Challenge 3: generation of inappropriate or offensive content. The model may generate text that is inappropriate, offensive, or harmful. Sample use case that resulted in Challenge 3: a user asked the model to generate a creative story. The model might produce text containing offensive language or harmful stereotypes due to its exposure to diverse content during training. Fixes to Challenge 3. Use a model that has been trained with safety and ethics in mind. Implement safeguards and filters to prevent the generation of inappropriate content. Carefully review and edit the model's output to ensure it is appropriate. Challenge 4: difficulty in handling complex reasoning or logic. The Anthropic model may struggle with tasks that require complex reasoning or logical inference. Sample use case that resulted in Challenge 4: a user asked the model to solve a riddle or a logic puzzle. The model may not be able to understand the underlying reasoning or make the necessary deductions to arrive at a correct solution. Fixes to Challenge 4. Provide clear and structured prompts to guide the model's reasoning. Break down complex reasoning tasks into smaller steps. Consider using a model specifically designed for reasoning or logic tasks. Challenge 5: limitations in knowledge acquisition. The model's knowledge is limited to the data it was trained on. Sample use case that resulted in Challenge 5: a user asked the model a question about a recent event that occurred after its training data cutoff. The model may not have access to the information and may provide incorrect or incomplete answers. Fixes to Challenge 5. Use a model that has been trained on more up-to-date data. Supplement the model's knowledge with external sources of information. Keep in mind the limitations of the model's knowledge and interpret its responses accordingly. YAML. Langchain Anthropic Output Parsers Extract Tool Calls. Description: the extract tool calls output parser is designed to extract tool calls from the Anthropic AI model's response. It analyzes the text, identifies any mentions of specific tools or actions, and translates them into a structured format suitable for Langchain's tool execution. Inputs. Anthropic AI model's response. This is the primary input, containing the generated text. It should include instructions for tool usage, potentially within a conversation context. Outputs. Tool call list. This is the output of the parser. It is a list of tool calls, each represented as a dictionary containing tool name, the name of the tool to be invoked. Tool arguments, a dictionary of key-value pairs representing the arguments to be passed to the tool. Steps. Text analysis. The parser first analyzes the generated text to identify potential tool calls. It looks for keywords, phrases, and patterns associated with specific tools. Pattern matching. The parser utilizes predefined or user-defined patterns to match text snippets to specific tools. For instance, a pattern might include a tool name followed by parentheses containing arguments. Argument extraction. Once a tool call is identified, the parser extracts the arguments. It may use techniques like regular expressions, named entity recognition, or semantic analysis to extract and structure the arguments. Metrics. Precision. The percentage of extracted tool calls that are correctly identified and matched. Actual tool usage. Recall the percentage of actual tool calls that are successfully extracted by the parser. F1 score. The harmonic mean of precision and recall, providing a balanced measure of the parser's accuracy. Visualization plots. Tool call frequency. A bar chart showing the distribution of tool calls across different tool names. Argument value distribution. Visualizations depicting the distribution of argument values for each tool, helping to understand common patterns and outliers. Fine-tune parameters. Pattern library. This parameter allows users to customize the patterns used for tool call. Extraction. Users can add or modify patterns to improve the parser's accuracy for specific tools or tool usage. Patterns. Argument parsing strategies. Users can fine-tune the argument extraction strategies, such as using different regular expression patterns or implementing custom logic for specific argument types. Uncertainty methods. Confidence score. The parser can provide a confidence score for each extracted tool call, indicating the parser's certainty about the identification. Multiple interpretation. The parser can provide multiple possible interpretations of tool calls, especially for ambiguous or complex usage scenarios. Challenges and fixes. Challenge 1. Ambiguous tool call instructions. The generated text may contain unclear or ambiguous instructions about tool usage, making it difficult for the parser to accurately identify the tool call. Sample use case. Please use the weather tool to get the temperature in London. Then, display the information in a table. This instruction could be interpreted as two tool calls, one for weather and one for table creation. Fixes to challenge 1. Improved pattern matching. Design more robust patterns that can handle variations in tool call instructions, such as using synonyms or alternative wording. Contextual analysis. Utilize the surrounding context to resolve ambiguities. For example, the mention of temperature could help identify the weather tool. Challenge 2. Unstructured tool arguments. The generated text may not always provide tool arguments in a structured format. Sample use case. Get the weather forecast for tomorrow in San Francisco. This instruction lacks a clear format for specifying arguments like location and date. Fixes to challenge 2. Argument extraction techniques. Implement more sophisticated techniques for argument extraction, such as named entity recognition or semantic analysis. User input prompts if necessary. The parser can interact with the user to clarify ambiguous arguments or request additional information.